Hello, class. So this is the second problem I'm going to go over that's going to be on your quiz. It is a division problem with scientific notation. So I'm asked to evaluate this problem, which is 3.4 times 10 to the 25th power divided by 9.83. So I need to evaluate it and put the answer in proper scientific notation. So our rule that we went over in class for evaluating problems with evaluating multiplication and division problems with scientific notation is to just ignore our base and our exponent. We saw this a little bit in the other video, but we were doing multiplication there, so here we're going to do a little bit of division. We just want to ignore this and just treat it like 3.4 divided by 9.83. That's our first problem. Our first step, 3.4 divided by 9.83. If we go in our calculators, 3.4 divided by 9.83, we find out we're going to get 0.345. So 0.345 is our value, but we ignored the base and the exponent, but we want to bring that down. We ignored it, but it comes along for the ride. It's 0.345 times 10 to the 25. This is the correct value for this equation. However, it is not in proper scientific notation. Remember, proper scientific notation has one unit, one digit to the left of the decimal. Here, we don't have any digits to the left of our decimal. So we've got to do a little bit more work. And it's going to start to become simpler, but basically what this means is that where this decimal sits right now, it actually, in long form, if we were to write this whole number out, it would actually live 25 decimal places to the right. Be somewhere over here. It's got to make a 25 digit spot jump. So if we want to move it to where it's supposed to be, where it's 3.45, where we correctly have one digit to the left of our decimal, now instead of going 25 decimal places, 25 digits over, it's only going to go 24 digits over now because it's one decimal place closer. 3.45 now becomes times 10 to the 24th power because it is one space closer to where it's supposed to be written out in long form. So that number goes down because the jumps it took is not as many jumps as it was for 10 to the 25. 3.45 times 10 to the 24, we're not working with any units here. I don't have any units for this problem. I don't on the quiz either. So this is the correct answer. The other video I have has this worked out for a multiplication problem. You can check that one out. The second part of it does. But this is how we do that. 3.45 times 10 to the 24th power. Our last question, and it's our third and final question that's going to be on our quiz. I'm asking, which element has a greater molar mass, manganese or tin? Now, what we got to do, how we find out our molar masses, we look right on our periodic table. So we're working with manganese and tin. I want to find out which one is a greater molar mass. So first things first, I got to find manganese, and I'll read its molar mass right from the table. So it's manganese. Kind of sounds like magnesium, but manganese, Mn, is its own element. It's got a molar mass of 54.938, so we'll write that in. 54.938, and the units on molar mass is grams per mole. What those units mean is that if I had a mole of manganese. If I had 6.02 times 10 to the 23 atoms of manganese, in real life, it would have a mass of 54.938 grams. That's what that unit means. 54.938 grams per mole of manganese. So, found that one. I want to find out which one is greater, so I've got to look for tin now. Tin is weird. It's got a atomic symbol of SN, and it's got a molar mass read right from the periodic table of 118.711. 118.711. I don't need you to carry all those digits with you, but reading right from the table, that's what we get. And again, our units are also grams per mole. It's the same thing. If I had 1 mole of tin atoms, if I had the same number of tin atoms as this mole right here, just a different type of atom, if I had a mole of tin atoms, they would have a mass of 118.711 grams. So we can easily say here now, we see that 54.938 is not as big as 118.711, so tin is going to have our greater molar mass. Remember, these numbers are read right from the periodic table. They will be on every periodic table that you get. If you have trouble finding out where an atom is, you can check the back. It's got them all listed out in alphabetical order. We see manganese, Mn is the atomic symbol we're looking for, and it also has the atomic mass listed right here. And so atomic mass and molar mass have the same value. So we see it for manganese, it's 54.93. For tin, it is 118.71. So they just chopped off a digit that we didn't. But we can see there, if we need help finding it, and we can see that tin has the greater molar mass.